In this chapter, we start looking at a class of compounds known as ionic compounds and trying to establish why ionic compounds form and what kinds of atoms are going to form ionic compounds. A key to understanding why ionic compounds form is to understand something called the Octet Rule. Now, to understand the Octet Rule, we have to think about what atoms are stable and are not chemically reactive, and what atoms are unstable and like to form bonds to other atoms. Now we know that the least likely atoms to react on the periodic table are those in group 8a, what we call the inert or noble gases. And when we look at the inert gases, what we observe is that they have an outer shell with complete S and P subshells. In the case of helium, this means that it has 2 electrons in its outermost shell, finishing off an S subshell, and for all of the other atoms in the noble gases, they all have 8 electrons in their outermost shell, completing an S and a P subshell. So what we know is that if an atom has one of these electron configurations, then it's very stable and it doesn't form chemical bonds from then on in. So what we can conclude is that the most stable electron configuration is the one in which the atom has a complete outer S and P subshell. That is, that they have an outer electron configuration that looks a little like that, where N is the number of the highest shell. So what we're going to observe is that atoms that don't have this noble gas stable electron configuration, they're going to get it through forming chemical bonds. And in this chapter, we're going to look at a particular kind of chemical bond called an ionic bond. So this idea is summarized by the Octet Rule and explains why atoms form chemical bonds to one another. So the Octet Rule states that when chemical compounds form, atoms will either lose, gain, or share, sometimes referred to as pooling electrons, so as to obtain a noble gas configuration of the atoms involved. That is, these guys are going to move electrons amongst themselves, or they're going to pool their electrons, share their electrons, so that they have a configuration like that of a noble gas which is unreactive. Once they've got that, they stop reacting and chemical bonds stop forming. So something that's important to recognize is that atoms have an equal number of protons and electrons, and as a result they have no electrical charge, because remember that the charge on a proton is +1 and the charge on an electron is -1. So if an atom has equal numbers of protons and electrons, then overall you will have electrical neutrality. An atom may lose or gain some electrons, and when it does, it will acquire an electrical charge and it will form what we call an ion. For every electron that is lost, an atom will gain one positive charge, and it will form what we call a cation. So cations are positive, is how I remember this. Okay, and the important thing to recognize is that for every electron that our atom loses, we gain one positive charge. So if we have an atom that loses 2 electrons, it'll gain a 2+ electrical charge, and if we have an atom that loses 3 electrons, it'll gain a 3+ electrical charge. The atoms that form cations, that form positively charged ions, are hydrogen and the metals. They all form cations. Now, if an atom gains 1 or more electrons, then it'll form a negatively charged anion, and for every electron gained, it gets a 1- charge. So if I look at something like oxygen likes to gain 2 electrons and acquire a 2 negative charge. If I look at something like phosphorus likes to gain 3 electrons and acquire a 3 negative charge. So the important thing to recognize is that for every electron gained, the atom acquires one negative charge. And what atoms form anions? Well, nonmetals form anions. Now, it's important to realize that because anions and cations are oppositely charged, they attract one another. I should also mention at this point that you can remember that anions are negatively charged because we've got a negative ion are the first three letters of the word anion. There we go. Okay, a negative ion. Now, anions and cations, as I was saying, they are oppositely charged. Anions are negative, cations are positive, and so therefore they will attract one another. So anions will become stuck to cations. Okay, so that's our little introduction to the chapter and a brief explanation of the octet rule. I hope it was helpful.